Welcome to the presentation on figuring out the slope. Let's get started. So let's say I have 2 points, and as we learned in previous presentations that all you need to define a line is 2 points, and I think if you think about that, that makes sense. Let's say we have 2 points, and let me write down the 2 points we're going to have. Let's say one point is, well, why isn't it writing? Sometimes this thing acts a little finicky. Let's see, oh, that's because I was trying to write in black. Let's say that one point is -1, 3. So let's see, where do we graph that? So if this is 0, 0, we go -1. This is -1 here. Let me just write -1, and then we're going to go 3 up. 1, 2, 3, because this is 3 right here. So -1, 3 is going to be right over there. Okay, so that's the first point. And the second point, I'm going to do it in a different color. Let's say the second point is 2, 1. So let's see where we would put that. Well, we'd count 1, 2. This is 2, 1, because this is 1. So the point is going to be here, right? So we've graphed our 2 points, and now the line that connects them is going to look something like this. And I hope I can draw it well. No, that's not a good line. Let me try to do it better. I'm just going to go straight from this point through that point, like that. And then I'm going to do it, and then I'm just going to try to continue the line from here. That might be the best technique. Something like that. That's close. Whoops, the microphone dropped. As you can tell, this is not a completely professional operation. The microphone's dropping. Okay, so let's look at that line. So what we want to do in this presentation is figure out the slope of that line. So let's write out a couple of things that I think will help you. So there's a couple of ways to view slope. I think intuitively you know that the slope is the inclination of this line, and we can already see that this is a downward sloping line because it comes from the top left to the bottom right. So it's going to be a negative number, the slope. So you know that immediately, and we'll have what we're going to do is actually figure out how to figure out the slope. So slope, let me write this down, slope, and oftentimes we'll use the variable m for slope. I have no idea why, because m clearly does not stand for slope. That is equal to, there's a couple of things you might hear, change in y over change in x. That triangle, which is pronounced delta, just a Greek letter, that means change. So change in y over change in x, and that also is equal to rise over run. And I'm going to explain what all this means in a second. So let's start at one of these points. Let's start at this green point, -1, 3. So how much do we have to rise and how much do we have to run to get to the second point, 2, 1? So let's do the rise first. Well, we have to go -2. So that's the rise. So the rise is equal to -2. Right? Because we have to go down 2 to get to the same y as this yellow point. And then we have to run, right there, we have to run +3. So rise divided by run is equal to -2 over 3. Well, how would we do that if we didn't have this nice graph here to actually figure to draw on? Well, what we can do is we can say, let's take this as the starting point. Change in y over change in x is equal to, we take the first y point, which is 3, and we subtract the second y point, which is 1. Right? You see that? We just took 3 minus 1, so that's the change in y, over, and we take the first x point, -1, minus the second x point, minus 2. So 3 minus 1 is 2. And -1 minus 2 is equal to -3. So same thing, we got -2 over 3. Now we could have done it the other way, and I'm running out of space here, but we could have made this the first point. If we made that the first point, then the change in y would have been, let me see if I want to make it really cluttered so to confuse you. Change in y would be this y, 1 minus 3 over change in x should be 2 minus -1. Well, 1 minus 3 is -2. And 2 minus -1 is 3. So once again, we got minus 2/3. So it doesn't matter which point we start with, as long as if we use the y in this coordinate first, then we have to use the x in that coordinate first. Let's do some more problems. And actually, I'm going to do a couple just so you see the algebra without even graphing it first. So let's say I wanted to figure out the slope between the points 5, 2 and 3, 5. Well, let's take this as our starting point. So change in y over change in x, or rise over run. Well, change in y would be this 5 minus this 2 over this 3 minus this 5. And that gets us 3, this is a 5, over minus 2 equals minus 3 halves. Let's do another one. And this time I'm going to try to make it color-coded so it'll be more self-explanatory. So it's 1, 2, that's the first point. And then the second point is 4, 3. So once again, we say slope is equal to change in y over change in x. Well, change in y, we take the first y, let's start here, and we'll call that y1. So that's 3 minus the second y, which is that 2. And then all of that over, once again, the first x, which is 4, minus the second x, which is that 1. And this equals 3 minus 2 is 1, and 4 minus 1 is 3. So the slope in this example is 1/3. And we could have actually switched it around. We could have done it the other way. We could have said 2 minus 3 over 1 minus 4, in which case we would have gotten -1 over -3. Well, that just equals 1/3 again, because the negatives cancel out. So I'll let you think about why this and this come out to the same thing. But the important thing to realize is if we use the 3 first, for the y, we also have to use the 4 first for the x. That's a common mistake. And also, you always have to be very careful with the negative signs when you do these type of problems. But I think that will give you at least enough of a sense that you can start the slope problems. The next module, I'll actually show you how to figure out the y-intercept, because as we said before, the equation of any line is y is equal to mx plus b. And I'm going to go into this in more detail, where m is the slope. So if you know the slope of a line and you know the y-intercept of a line, you know everything you need to know about the line, and you can actually write down the equation of a line and figure out other points that are on it. So I'm going to do that in future modules. I hope I haven't confused you too much, and try some of the slope modules. You should be able to do them, and I hope you have fun.